Alright, draft physics video. A couple of things I'm going to do here. So yeah, it's going to be a little sloppy, and probably should use the light table and whatnot, but it's kind of real draft stuff, just stuff I've been thinking about. So I don't want it to be a official type video. In the other half of the video, I'll deal with the typical kind of Day argument of appeal to movies and the same old talking head bullshit. And so I'll play some of this, just places in this video where, you know, this guy's just so full of shit in at least 3 or 4 places. So I'll do the gravitational wave thing just because it's kind of hilarious. But anyway, alright, the thing I was thinking about is a couple of subjects. And the first one is a way of, you know, you can go look up, you know, this curve that is essentially the same curve that Einstein uses for the bent space, that is the well that goes forever, is essentially the same curve that they talk about for bent time. Okay, they're just taking the same bending and just turning it around and saying that's time dilation. So you dilate more, you know, excessively at the end and not so much in the beginning, kind of a thing, or something like that. And it's basically the inverse of the inverse square rule. So again, I'll try to explain just how dramatic it is as a rule, in the sense that you have this thing called infinite space, you know, and you're talking about a force that dilutes rapidly into an infinite field. And so you can pretend that the stuff after 10 feet matters, but the point is the stuff after 10 feet is so fucking irrelevant you can't believe how irrelevant it is. And it appears the opposite way when you invert the curve. Yeah. So anyway, it's just mathematical crap. That's what it is. It's just crap. Alright, so I guess the easiest way to do it is do this bullseye thing, I think, which you know, I just drew it wrong because it's worse than even I drew it. The reality, see, okay, I drew it like this, so this would be the sun, let's say, and I was going to go a radius away, and I went a diameter away. So I already blew the drawing. That's how bad this is. So let's just draw another circle inside. See, you really have to get tight. Okay, so the idea is you can sort of understand that if I take a small p, and then I go the radius of the p out, and then make another p, it'd be big. So it's 4 times the circumference or surface area, the sphere. And if I go one more little radius out, okay, then it's yeah, it goes 4, 9 times. All right, so it's all it takes, tiny amounts of distance. So just just half the diameter of the sun. We go half the diameter away from the sun, and now the gravity is 1/4. So that means it was 70 meters per second, and now it's cut all the way down to 20 or less. No, it's more like 15. So now it's only 5 meters per second stronger than the gravity here on Earth. Just 1/2 of a diameter, just one radius away from the sun's surface, and you're already out of luck. No chance of lensing, no chance of doing anything interesting, because it's Earth gravity now. And we know we can't do lensing on planets that are this, you know, they're not big enough, they're not heavy enough, not enough gravity. A surface gravity. See, that's the key thing too, is suns are shitty for lensing. I know they're big and they're heavy, but they're shitty for lensing for 2 reasons. The first reason being, you know, they're light, they're not made of heavy stuff, and the second reason is they're on fire, which is really bad. So you can sort of get my point, right? I'm already here at just one radius. So just one radius away from the sun, all right? You're already fucked. And we know the fire on the sun shoots way the hell up. I mean, really far. So the sun is really on fire. And there's all kinds of stuff flying into the atmosphere around the sun. And so you got to figure that at one radius away from the sun, that's probably still a pretty hot place to be. You know, if you were hanging out there, you'd be feeling, you're getting irradiated, right? Not only radiation, but yeah, lots of. It's a pretty hot place to be, you would imagine, correct? Come on, let's not fool ourselves. Very hot place to be. Lots of stuff coming off of the sun, just one radius away from the sun, and that's where they want to try to lens something. So right there, I think they were out of luck, in my opinion. I mean, what's the prospect of you being able to lens on the sun when you know the sun is producing a huge amount of energy and that the atmosphere around the sun is going to be full of all kinds of atomic particles and their remnants that'll take, some of them might take a year to fall back into the sun. They're shooting out, they're bending. You've seen those pictures of the big arcing flames. Well, those are the big arcing flames. Imagine how much radiation you can't see is arcing even bigger. Big, huge arcs of energy flying off of that sun. And I mean by energy, material matter being pushed by force. I mean material. So the point I wanted to do with this drawing was just to illustrate that when they really want to do this thing fair, if you want to do a curve, then the curve ought to just go with little suns, right? It ought to just show little suns, and it ought to just show the curve of gravity. So here at the one sun, it's really strong, and by the time you just get, you know, a few tiny little suns away, you're already down to almost nothing in terms of the gravity. I mean, you're talking about, you went from, just right out here, you went from meters per second to millimeters per second in that distance. The gravity from the sun that's affecting the Earth is actually, you know, people just wouldn't believe. If I gave you the numbers, like 0.00042 meters per second. I mean, it's a preposterously small amount of gravity that actually keeps the sun in the orbit. So anyway, so I just thought I'd make that clarification. So this is the line, you know, and all they did is they took that line, you know, to do this time dilation crap. They take that line and just turn it going this way. And they say, see, look, nothing happens for a long time and all of a sudden something happens. And that really isn't the way the curve should be drawn. And it also is deceptive because, again, it's based on Einstein's gravity well, which, in my opinion, is a pile of crap because the well doesn't have a bottom and force has a bottom. There's only so much stuff that can push things. I know you people just can't get it, but that's how it's working. You're getting pushed onto the Earth. The Earth is getting pushed into the sun. And there's almost so much push out there in the universe. The universe is full of quanta, but there's only so much of it. And it can only make so much shit move so fast, and that's it. And then it's all out. It's all out of juice. Alright. So, the other thing I thought was interesting thinking about it. Alright, so I'm thinking about this electron thing and how it creates a photon. So I was doing the thing where it is kind of interesting just to think about electrons and the idea that when they get closer together, you increase the stuff trapped between them. And in a sense, that stuff is always there. No matter where the electron goes, it's going to well, it's not no matter where it goes, though. So that's where it gets a little complicated. But you can sort of understand there's no way to bring things together without trapping. So I'm just saying, well, you can take my word for it. I mean, it's a little, you have to think about it for a while to realize it. But if I take two things in space, there's no way I can bring them together without trapping stuff between them. Pretty sure of that. Yeah, anyway, there's just, you just can't avoid the trajectory problem. But anyway, so the point would be is that this frequency would increase as two things get closer, get pushed together. So whatever's between electrons would get compressed, and that stuff would be bouncing back and forth, and that would be your light frequencies. So the most common distance that electrons have would essentially be the frequency of stuff like, you know, infrared light or something. The most, whatever the thing is that's produced the most by suns, is really a reflection of the most standard position of the electron. So the more compressed the electrons are, the higher the frequency of the radiation they could produce, and the less compressed they are, the lower the frequency of the radiation they'll produce. But then there was another way of thinking about it, and thinking about it in terms of reflections and all of that kind of stuff. So there's just this simple idea that electrons can essentially communicate force to each other through this perpendicular principle. So you can think of the electrons as being polarized this way, and the protons are polarized this way, or you can turn them into polarized film, I suppose, but it's probably more complicated than that. But it might be that. It might be something like that. That's simple. But regardless, the point is, when stuff of the wrong polarization goes in, it doesn't go out backwards, it goes out sideways. So the idea would be is that there's this perpendicular thing. So this is all Maxwell kind of stuff. So the force goes from one to the other, and then from the other to the other, and from the other to the other, and from the other to the other. Now there's no automatic rule that says this didn't go that way instead, and this didn't go that way instead. But the point is, it can go in a circle. All right. So I was thinking about reflections and how electrons are on the surface, and they're in an arrangement. And so there's different ways to try to figure out how when a photon comes in at different angles, how is it affecting that electron, and how does the angle stay the same? So we know that if I come straight in, we know that the electron kind of just goes back. Okay, and it moves back this way, and you get what might be considered the cleanest of reflections, if you get any reflection. The rest is transmission, in the sense that the electron pushes another electron, and they push the force into the material, and then at some point it gets pushed perpendicular, and it moves through the material as force. If it's not reflective. Now, if it's reflective, then it's doing something different, and that's what I'm trying to get to. So there's different ways of thinking about reflection. So what I was thinking about was this box idea, because it does solve the problem in a sense. And there's just different ways you could interpret it, though, so I didn't know. It's not something I'm glued to. But it sort of wouldn't matter what angle. So it almost doesn't matter what angle I put this in. So I can have come in at any angle. And what essentially is going to happen is on this surface, it'll come in, and it'll do this box thing. Okay, it'll hit an electron. That electron will create force, and then that force will hit another electron. It'll create force, all 90 degrees, and you'll end up with the same angle going out. So angle of incidence equals angle of reflection. Because and it wouldn't really matter how long any one of these. All you need is the 90 degrees. So it doesn't matter, like if this went further and then it hit an electron, so it wouldn't matter whether it's a rectangle. It wouldn't matter how you deform the square geometry, as long as you have the 4 right angles. So I was thinking that's a pretty interesting fact. But you also have like a shorter cut to that, which would be for the reflection, the amount of light that reflects back, which I'm trying to figure out with this stupid light tube, because it's still bugging me. Just trying to figure out exactly what's doing that. Because there's 2 reflections. Okay, so the light's coming in, it's reflecting off the interior surface, and some of the light comes to the camera, and some of the light bounces up to make the next biggest ring. And then some of that light comes to my eyes, or through the camera, in this case, to you, right? You can see that pretty well, I think. Ooh, that was good. Yeah, ooh, you got it right. Ooh, you had it. Okay. Yeah, getting it. Ooh, oh, that's good. Ooh, yeah. Oh, yeah. Do it some more. Well, anyway. So each ring is actually an inverse, so you can tell it's bouncing from one surface to the next surface, so it's crisscrossing across the tube. And at each reflection point, part of the light, obviously, is coming to us. Part of the light is reflecting to the next surface, forward onto the surface. So there's 2 reflections at 2 different angles. That's interesting, because I don't know why that is. So that's why that's interesting, right? I mean, 2 reflections are happening. A portion of light's coming this way, and a portion of light's bouncing up and to bounce down again, to bounce up, to bounce down. And at each bounce, a portion of it is going at this very acute angle to my eye. Quite interesting. I mean, I guess should have drawn a picture of it, but I could draw a quick picture. So what I'm saying is happening is the light's coming in. It's the light at some angle. So it hits this surface, and then light goes this way. But some of the light goes this way, and it hits this surface, and some of the light goes this way. But some of the light goes down this way. See? That's what's happening. I'm thinking. I mean, that's the only explanation I can come up with. Maybe somebody has a better one. So there's two reflections. So anyway, I was thinking about that in the sense that in this same example, you could kind of think of this as like, well, I'll just draw it again because there'll be junk in the way. So you could come in and you could say, okay, you hit an electron, and that electron shoots it perpendicular right away. That hits another electron, and it goes right back out. And so it would be very parallel, this backward reflection. But, you know, likewise, it could do exactly the opposite. It could move the electron forward this way, produce the parallel that way, and that would also get you your angle. It's just part of me thinks that the photon is different than the communicating force. So this is where you get into polarization, where it gets kind of interesting, because rainbows are polarized. So when the sunlight goes into the raindrop, it's segregating the polarization and only projecting to us a polarized image. You know, only the polarized light is being reflected as a rainbow, and the non-polarized is absorbed or doesn't make it through the system. So I think that's an interesting, curious. So there is some filtering going on. So I'm just saying there's mechanisms where you could argue that the square gives you the ability to do the U-turn, and then the square also gives you the ability to do preserve the angle. So it gives you both options, which is interesting. Okay, so I think so I just want to do that lensing thing and this thing, and I think that's the stuff that I was thinking about today anyway. I don't know if there's anything else critical. Yeah, it's just still the movement of the electron bouncing into the force. You know, the electron pushes into the other electron and gets pushed back, and it's the pushback where I think the photon's created. So that's just, I'm just saying it's like a spring. The electrons are connected by this pressure, and when you hit one with a photon, it goes a little bit into the pressure, and then the pressure just forces it back out. And it's on the back out trip where it finds, and then the pressure's equalized because there's pressure coming this way too. And so the electron wants to go back to its standard position. So it's essentially just saying that the electron is sitting in tension. And it's just sitting there. I'm tense. I'm being held by different pressure from all directions, and I'm just staying here because it's even pressure basically. And then you hit it with a photon, it moves a little bit in that extra direction. But that extra direction has more pressure. Can't stay there. So it gets pushed back to where it was. And once it gets back to where it was, it gives back the photon, because the force is going back into force again, and that's going to decelerate it, and that through the process of the deceleration, it gives back the energy. And that's the photon. All of these are viable explanations. I just, got to play with them to figure out which ones have some sort of problem that make them impossible to consider. But the reason, part of what I was thinking with this idea of the square versus this square, is the idea that there would be a probability question of where you could ask the question, well, what's the probability of the, so you have the first interaction, the electron's guaranteed to move to this spot. The probability here is 50-50. The energy goes this way, Okay, which it looks like it's going to be heading out anyway. And that would be angle of incidence, angle of reflection, because you have a 90-degree angle here. You know, that's the great thing about this, is you always create 90-degree angles. So that's your first probability, is you go this way or this way. So you have the 50% chance here of a fast reflection, the U-turn, okay, the smaller box. Well, no, it's really just the reflection, essentially. I mean, it's a reflection through two interactions. And then 50% of them will go this way. Alright, the ones that go this way will hit an electron here. Now this electron can go this way or this way, so there's only a 50% chance it makes it to here. And then it goes to this electron, and there's only a 50% chance that it'll go the right way here. So to go through those three interactions at 50%, then you're getting down into those numbers where you say it starts to make a little bit of a sense when you start to think about there's only a, like on glass or something, there's 8% reflect, well 4%, and it depends on the thickness of the glass. So yeah, the average is 4%. I think. Yeah, I'm just pretty sure it was 4 of the light reflects. And so that might be just what you end up with to go through that, what's necessary, which is the real reflect. You have to do the more complex reflection to actually not get transmitted through light. I mean, transmitted through the material. And the probability is increased as you increase the angle. Then everything reflects it. After you go I don't know, is it a Brewster angle? I don't know what angle it is. There's some guy's angle. Once you get that angle, everything's reflecting. Nothing is transmitted. Alright, well, I don't want to get into... I mean, that's a subject for another video, is the whole refraction and reflection. So, yeah, I guess I'll write that as a video title, a subject title. That one's going to be a bitch. Yeah. There's just so much to it, right? I mean, there's so much to figuring out whether these are fundamentally surface phenomenons or whether it actually does have something to do with the transmission through the mediums, and then you get into lenses, and it really gets to be gnarly. Refraction. But let's understand too, this guy says, well, it creates a convex lens. He says that in here. And gravitational lensing creates this. This is your fucking lens. Yeah. Okay. Yeah. Oh yeah, that's a cool lens. It looks really cool, but I bet you can't see shit through it. So anyway. So let's play some of this crap. And I'll point out just some of the obvious crap of it. And it's all, I don't think Einstein had too much right. I mean, beyond his early years, okay, any of the relativity crap and the bent space crap is, in my opinion, crap. The rest of his stuff is good, his math is good, but the explanation for why the math exists is crap, and the fact that the math doesn't have any rational ends is crap. So, but anyway.
Theory predicts that the system will emit gravitational waves.
Alright, so this is a video he's played before, because I know I've seen it before, and I don't know, maybe I looked for it, I don't know. Proving Einstein right is the evidence, and this is some, whatever, British guy, obviously.
A single rotating...
I mean, he obviously worked on these projects, these funded projects. Let's remember where the money goes. And so, of course, he's going to think this is great science. So there's a bit of a prejudice here. I'll say for the record now, because I might not get to it. Maybe I won't find that clip and just jumping around in here. He said about the Einstein, I keep getting that guy's name, Eddington. Yes, there was 2 tries. The first try, they didn't even talk about it because it was such a gross failure. And they were all really disappointed because, oh shit, blah, blah, blah. But it turned out just 8 years later there was another solar eclipse. And I think that's the 1922 experiment. And this guy said everything went fine and it was a great experiment. I mean, no, it wasn't. It was a suck experiment. So I mean, right there he loses all credibility, doesn't he? There was no validation experiment. I mean, that was it for Eddington. He didn't have another shot. The game was over. So that's right there. It's just a gross mischaracterization of the truth by this guy, and he's supposed to be talking about proving Einstein right with garbage evidence.
The star will not. If you put a stick into a lake.
So this is gravitational waving. So here we go again. We got another guy. We can't do physics apparently. Nuclear physics without sticking sticks in fucking water. Or dropping something in fucking water. I mean, these guys can never escape this stupid water metaphor, which is a fucking ether metaphor, which they have supposed to have been disposed of. There isn't supposed to be an ether. And as soon as you start talking about sticking a stick in water, then you've turned your bent space into fucking ether.
Pond, and you sort of do that to it so it's rotating. I don't think it would cause any ripples. Certainly if it's smooth.
Well, yeah, certainly, and you spun it perfectly roundly, in a perfect center, which is not likely. But anyway, who cares? Like most of the things orbiting aren't shuddering right now. So they are spinning and shuddering. They are vibrating. So why aren't they waving all over the fucking place? Yeah, right.
If you had two sticks and you actually rotated, if you put them on a bar and rotated that bar, I promise you would actually...
Right, and why would you see waves? Because it's water. The molecules are stuck to each other, and you're pulling the water around two sticks. So you're stirring it. You're stirring a medium. How is this applicable to what gravity is supposed to be? It's not supposed to be a frickin' maple syrup.
See some ripples going out. I think this is the idea coming up next. Something like that.
Okay, so something like this, right? So this is where they got this stupid spiral. I didn't know where they got this stupid spiral from, but this is what they're thinking. They're thinking there's two objects. They don't have the second one drawn here for whatever dumbass reason. So there's two sticks, and they turn the sticks, and they're talking about how the medium is getting pulled by the stirring, and then the wave from the pull is being pushed out. So that's how they created this nonsense. Now, you want to know the truth about what Einstein said? He didn't say this shit at all. He didn't talk about stirring bent space. Yes, you could stir the bent space and blah, blah, blah. What Einstein said was, look, they knew that these pulsars existed, the blinky shit. And they speculated the blinky shit is being created by two bodies on fire that are spinning around each other. And that's one's on fire and one's not. So it's a sun with a big black thing or something. And that's what's making the blink. Okay, the black thing keeps going in front of the hot thing and keeps blinking it off. Blink, 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 okay? And so the theory was, no, it's two things in non-centric. Okay, yeah. So it's more like on, off. Well, I don't know how it could be off, unless one of them wasn't on fire. Well, it doesn't matter. They knew about this idea as two things spinning around each other. So let's just say that's what the theory was. And the light blinks. And the question to Einstein was, and this was kind of like something that was posed to him, if we know that these things on Earth can create frequencies when that happens, and we can detect the frequencies like in sound and other things, radio waves, that was all, beginning of the 1900s. That's when they were figuring out all this shit. And so the speculation was, well, wouldn't that circumstance be like a beacon? And wouldn't it not only just create light at a frequency, but wouldn't it create gravity at a frequency? Wouldn't the gravity be turned on and off? So it's not like there were waves. The idea would be is that the gravity would be strong and then weak, and then strong and then weak. Because the things would be lined up, the two gravitational bodies, and then they'd be spread out. So that was the idea, is strong gravity, weak gravity, strong gravity, weak gravity, strong gravity, weak gravity. That was what Einstein was talking about, as I understand it. Not this shit. Because this shit requires a medium that transmits a wave, that takes force and and has it move through the bent space. Einstein never talked about anything moving through bent space. Not that I ever saw. So again, they're putting Einstein's name on this crap, and I don't think this crap has anything to do with what Einstein theoried to be the reality. Alright, so I don't know if I need to go any further than that. So let's just remember that what they speculated with this stupid gravitational wave thing is two giant black holes from who knows where somehow magically got into an orbit with each other, which is really complicated. Like, you have to hit something to actually get into an orbit with something else. Somebody had to hit something. That's not explained. It's not explained how you even give velocity to a heavy object. Heavy objects, to have velocity, that means they had to be hit by a lot of force. A lot of things going the same way had to hit them for them to have high velocity. None of that's explained. It's also so, and then what happened? They finally crash into each other, go chirpity chirp, and then the mass of the suns degrades somehow, not into force, not into light or radiation or energy. No, it degrades into bumpy, bent space. So they convert matter into bent space. That's what the argument is. They convert 3 solar masses of matter into a bend in bent space. And you fuckers are going to argue about my credibility? Shit. Alright, so let's play with some of this. Alright, that's the Mercury orbit thing. So that's another one of these canards. Oh, why it's trying to... Oh, there, I found it. You know, what Einstein figured out was just that the orbit of Mercury, the key factor is that Newton didn't account for the sun, center of gravity moving, and that's what fucks the precession of Mercury. And obviously, the vibrations of the sun mean almost nothing when you start getting out into this thinner and thinner gravity. So again, it's the inverse square law. The further away you go, it gets preposterously weaker. So, like, you know, insanely weaker. It's that line. It's just go weak so fast. So obviously the only thing the sun's movement would have an effect on, because the sun is so massive, would be something close to it. So it has nothing to do with anything magical. It just has to do with accounting for a movement Newton couldn't account for because it was unanticipatable, in the sense that Newton's equation was kind of simplistic. He did the M1 thing plus the M2 thing. Said, here's the force, just combine the two. And they're separate gravity engines, essentially. You can't combine the two. That's breaking the superposition argument. The two forces really aren't the same force. It's two independent forces. Earth creates one force, sun creates another force. Or the inverse, absence of force, if you want to call it. Gravity is essentially absence. Alright, so we'll move along. See what this part is. See if we get to the Eddington crap. But I mean, every one of these examples, I'm sorry, yeah, I thought this video would play. Silly me. Let me try refreshing the page. See if we get any. See if we get lucky. Have the video load in a manner in which it has some searchability.
And you see these lovely arcs here.
Yeah, lovely, lovely.
Any talk I've ever given said they understood tensor calculus. I certainly don't. But there's a nice story. He went to America, to New York.
Let's not bother with that.
Britannia, I think it was. With Chaim Weizmann.
Yeah, who cares?
So what is gravity? Well, Einstein's theory predicts that mass will distort the space-time around it, giving the space positive curvature.
Yes, positive curvature, which means I mean, I don't even know why they say something like that, right? I mean, it's obviously a negative function. I mean, it's obviously not a positive curvature. And obviously this bent spacey fabric thing is not a very good example, in the sense that, especially when you use it mechanically. because you can't create it frictionlessly. So it deceives people that they don't really realize how gravity really works, and that in real gravity, if I push something, if I have something right on this edge, and there's something gravitational, like this is a lousy well, by the way. I mean, the well should be a little deeper than this. But if I push something into the gravity at any one point, place it, and I just let it fall into the gravity, it'll either hit the thing or it'll fly out somewhere on the other end. But it won't go in an orbit unless something else interferes with it. It has to hit something else to lose velocity, or it won't stay. It'll either go directly and hit the thing in the center, or it's gone. Unless it hits something else. That's the, people just don't get that. I didn't get that part for most of my life, so I only found that out like the last year or two. That this is a deception, because gravity orbits are a lot more complicated than people think.
John Wheeler rather beautifully wrote, "Matter tells space how to curve. So you put mass into space, it curves the space around it. But then the space..."
Yeah, and then the space tells the matter how to move. I mean, and the fact that people can listen to that mush, that crap, that bullshit, and not say, God, that sounds like some sort of... The Holy Ghost whispers into God's ear, and then they both say, we're not doing anything. Hey, Jesus! Yeah, they get Jesus to do the work.
It acts like a gravitational lens. So that's the second thing in the way that Einstein predicted.
Right, so let's say, imagine stretching a rubber sheet, ball bearings roll across it in straight lines. If we lead a ball in the sheet, it will form a depression in the sheet, covering space around it. The ball bearing passing close will follow a curved path. Alright, as would a photon in curved space. So again, the idea that a photon is matter is a big, huge mistake, I would argue. I mean, it's not. I mean, it's force. It's not matter. Matter requires you to have the electrons and the protons. Even an electron and a proton is sub-matter. It's not matter. You can't give it inertia. You can't give it velocity that it can maintain on its own. There's just a huge gap here in just saying, well, I'm just going to establish that everything has some kind of mass, and so I'll give the photon this reality. It doesn't matter what its mass is. Obviously, we're just talking about making it part of the equation. So for some reason, all the rest of the equations apply to things that are material, and now we're going to apply it to a non-material entity. And we're skipping right over protons and electrons because they can't play at all. Because they're neither material nor are they light. So they don't even get to be part of this fun. Because the point is, in my opinion, they wouldn't play this game at all. And so, in my opinion, the very fact is that the game stops when you don't have an atom anymore. Playing the gravity game is over, okay, once you don't have electrons and protons.
So, in a region surrounding a mass, light will travel along curved lines. And as you can see there, the sun's mass, if that was the sun, would actually alter the position.
See, this would be a much more realistic way to do lensing, though. I don't know what I don't know what the gravity is on Uranus, or one of those kind of big gas balls that has a nice clean surface that probably doesn't have any crap flying around in it. Seems like those would be much better targets for doing lensing. So I have to find out, what their gravity. It's probably only like 32 meters per second or 64 meters per second. Probably just maybe a little bit too little. But anyway, this is just such a distortion. Because as I just pointed out, half the radius, so just about where they're putting this bent light, the gravity is already 4 times less than it is on the surface. So if it was 100 meters per second on the surface, you're down to 25 meters per second here, which is, just double what's on the Earth, a little over double. And the expectation is something going 160,000 miles a second is going to be deflected, bent by that. Now, if it was real matter, it would. So if that was an atom, and you moved it at 160 miles a second, 1,000 miles a second. In theory, this is what it would do. But light isn't an atom.
Of the stars.
And obviously you can't move matter at the speed of light, so you're fucked. Can't do the experiment. Damn.
That are observed nearby. So, in Einstein's view, the motion of the Earth around the Sun is simply the natural motion of a body through curved space.
Well, whatever. You know, I guess to say the natural motion is just almost to say my axiom is correct. So yeah, but to me it doesn't sound natural at all. It doesn't sound rational at all. It doesn't make any sense at all. Because in 3 dimensions it just turns into a vacuum cleaner. In 3 dimensions there's no way to explain where this convergence comes from. What the hell? There's no pushing force and there's no pulling force. There's just magical. The bend makes it happen through some sort of mathematical thingy-dingy. But there's nothing has to push, nothing has to really pull. We're just going to pretend it just follows the math. It follows the grid lines. There's grid lines. And the grid lines say, do this. Ether. It's ether all over the place. It's just bullshit. It's just finding the god of the gaps to explain it. It's not a real... Let's create fake dimensions and that'll solve our problem. The fake space dimension. Alright, anyway. I wonder what the red line means. Let's see what he says.
And this is something I made up, and I hope it's true.
Oh, okay, this is the part he made up. Gravity is the force that we infer to explain what happens. So gravity, we're just inferring it because the math is really doing it. Math does it, and we infer some sort of rational explanation, like something had to hit something and push it. Alright, in a curved 3-dimensional space. Okay, right, a curved 3-dimensional space. So here I have something 3-dimensional. And now I'm going to somehow curve every line going into the 3 dimensions in some rational way that makes sense in some way. When really all I'm going to do is converge them. I'm going to make an opposite of a light bulb. I'm going to have a suck bulb. And that's that's all this crap is. Bent space is just making a suck bulb. Alright, happens in curves. I mean, light bulbs are the thing, right? I mean, they'll teach you physics, okay? I mean, it's the same rule about how you get close to a light bulb and open your eyeball, and you're going to say, that's really uncomfortable. That's a lot more light. Yeah, same rules apply. Same rules apply to my fingers here. Look how small they are. Small fingers, and look, big fingers. Yeah, amazing. Anyway, what happens in a curved 3-dimensional space if we assume that space is flat, not curved? Oh man, now that's really impossible. So let's infer, and then curve the 3-dimensional, and then assume it was flat 3-dimensional. It's a flat 3-dimensional. Yeah, right.
I've never read it anywhere else. Gravity is a force that we...
I've never read it anywhere else. It's never been thought of anywhere else. Mr. Silly Pants. I'm going to call him names now because this is just silly.
Infer, we make up, to explain what happens in a curved 3-dimensional space if we assume that space is flat, not curved, because we can't...
If we assume it's flat and not curved. I mean, it just doesn't... How can anybody make sense out of that rubbish? But even just the idea, it's not a force. I mean, it's just, you know... Again, I mean, you people just can't see how it has to be a force. It just kind of has to be, and you'll never unify anything if you don't think it is a force. It's playing by the same fucking rules.
Conceive of curved space, so it's a force we make up. So that might become clearer with...
Yeah, well, whatever. It's a force you negate to make.
The second, slightly stretched.
You don't take any account for pretty much the thing moving the biggest objects in the universe, and we'll just pretend that isn't part of physics. You know, that's Bendixics.
Idea. Supposing you had a planet, and the people on that planet are totally convinced the surface of their planet is...
Why was Holiday popping up in here? Oh, yeah, he was right in here somewhere or something. Why the hell was he popping up in there? That's weird. Yeah, there he was. How the hell did he get in there? There he was again. There he is. Next. Oh, okay. That's not next. I don't understand that at all. This isn't an old video. Yeah, January 31st. Anyway.
Flat. Do you remember the Flat Earth Society? Okay. Now, somewhat towards what we know would be the North Pole, but of course they have no conception of that. The region is covered with, let's say, a frictionless ice.
Oh, fuck this.
They might therefore get somewhat upset. Made the Earth of lead. That obviously makes the Earth more massive. And the escape velocity would go up to 16 kilometers per second. Can you imagine if you kept on making the Earth more and more dense, put more and more matter into it?
Yes, and just pretend there's no limit to either how much you can compress the matter or how much the environment will provide you with more bent space, more space to bend. The space is unlimited spandex. I don't even know if Einstein thought that, but it seems like he didn't explain that. No, you'll rip the spandex if you put too big a weight on it. Too much fat in that spandex and it'll tear.
The escape velocity goes up and up and up. And you could perhaps imagine that eventually the escape velocity would reach the velocity of light. And if Einstein says that nothing can travel faster than that, nothing could leave the Earth. It was Pierre-Simon Laplace who realized that if you have a given mass or a mass within a given volume is sufficiently high, the escape velocity will exceed that of light, and so not be...
Right, so, and we know that that doesn't happen, all right? So we know that light isn't affected in terms of escaping, in terms of the direction it's moving. You can't slow it down, you can't speed it up. And we're just going to pretend, oh no, but you can certainly move it around this way all you want with gravity. Now you can't move it around this way all you want with magnetism, but sure, with gravity, yeah, no problem. Bullshit.
And light to escape. It was that wonderful John Wheeler who came up with the name black hole for such an object.
Yes, and we all believe in them, except haven't found any yet. Really, except for the theoretical ones. Oh, here, oh, he even shows that disgusting simulation. Cool. How can we detect black holes? Close your eyes and tap your heels together 3 times and go, there's no place like the black hole. Yeah, maybe that'll work.
That easy. I hope you can spot the one that's there. But you could possibly see one if you were near enough and it was in front of a nice star field, because it
yes, like it could avoid the star field. Like there's just so much space out there where there's no star fields.
It would form a gravitational lens and it would distort beautifully the star field behind it, as you can see there.
Yes, but no evidence of any of that anywhere. So yes, one of your theories is fucked. I think there's either no black holes or there's no lensing. One of your theories sucks. Big time.
And this is a lovely edge-on spiral galaxy I've actually imaged. And this is what you might see if a black hole went in front. You see the lights bending around the back of it. So you see it to the left.
Right, and again, these proportions seem a little bit silly. I'm sorry. I mean, just because if this is the black hole, this should be the event horizon. So we're already killing 45, 78 times the less gravity. So it's bending the light where there's 78 times less gravity. Doesn't sound right to me.
And now on this side you see the light to the right. You get a rather lovely effect.
Yes, blah, 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 based on completely silly math. So again, I wonder if their lens was a gravitationally proper lens when they did this experiment, or did they make it a sphere? It looks like they made it a bubble, and then did bubble mathematics, rather than make it what it should be, which is the gravity degrades sharply, getting sharper and sharper weakness. And so there's even less and less and less lensing. I didn't see any. I didn't see the image be really, really weak and they get stronger and stronger and stronger. No, I didn't see any of that.
Now, you've got to be pretty close to a
I mean,
black
it's a
hole.
big piece of crap.
I don't think we'd ever have a chance of seeing that, but you never know. Just see.
Well, again, if it's a black hole, I don't think you have to be all that close in the sense that you're certainly talking about, well, 770 solar masses, crammed into a whatever. It shouldn't be that hard to maintain that gravity. I guess it depends on really, yes, whether you have a realistic black hole or an unrealistic one. I mean, if the center of the black hole is still a reasonable size, you got a chance. But anyway, never mind. It's not happening anyway. Yes, one more time for the fantasy films. Yes, look how bright everything gets too. Isn't that very pretty?
If you have a black hole
Doesn't
in a
have a
binary
damn
system,
thing
that's
to do
when
with
you've got a black hole and star co-rotating around each other. Its mass, maybe tiny, we'll see about that in a minute, its mass pulls matter from the normal star onto itself. As matter accretes onto an object, it gets closer and closer, and conservation angular momentum makes it go faster and faster and faster, and you get lots of friction, and you can generate X-rays. So the
Okay, so the argument is the reason why X-rays are being produced by things isn't because the elemental matter, okay, is doing something. It's because the stuff trapped in the orbits is. I doubt it.
These things can cause X-ray flares, so making their presence felt. And that's the sort of idea there. You can see the matter is falling onto this unseen object, and nearby the center, you get X-ray emission.
Yeah, well, that's a really, did you get that with the Hubble telescope or something? No, I guess you didn't. I guess you drew that, didn't you? Yeah, you drew it. All right, let's see if he gets to the Eddington thing. Let's see what this one is. Giant X-ray flares. Oh, well, whatever. Yeah, I have my doubts about this crap. Let's see what this one is. Eddington had to be earlier, so.
And the middle was where they thought it was, and we found it 2 inches from the end.
Oh, yes, and we found it 2 inches from the end with our, wide wavelength, crappy laser. Let's see. Oh, here it is. Yeah, Einstein's theory. 1919 dubious, 1922 fine. There you go. It's right there. There's nothing fine about the 1922 results. Nothing at all fine about them.
And there's a square one, small 8-inch, that was about 12, I think. 8-inch, which was square, that was wood. Now, I've been to a few eclipses, and there's one thing that happens during an eclipse, which is what? It gets dark, yes, I know that. It gets cold. What does metal do when it gets cold? It contracts. So that big telescope went out of focus. You see that? The little one worked okay, and the one in Principe seemed to be okay. So they took the results, and some people say that he ignored the measurements that didn't fit Einstein and took the ones that did. So I said it's slightly dubious, his confirmation of Einstein. Probably not too bad, but in 1922, in fact, it was done again, and that was totally obvious. So that.
Yes, totally obvious. Okay, so I guess I'll have to look that up. Because I haven't seen the totally obvious results. But anyway. So yeah, we'll just hit a couple of this stuff because some of these stories are just so impossible. Okay, this one was interesting. So they take radio waves, or so he says he can focus them. So they're really highly focused radio waves. So it's like laser beam radio waves somehow. Radio telescopes, right? Sure. And they shoot them to Mars, and then they come back. And so the trick is what they say is that if and so this is the time it takes as a straight line. But if the sun's in the way, then it's not a straight line because it's bent. Part of me says that's not what Einstein would say, right? Because he would say that time wouldn't be slower for our perspective, it would only be slower from the light's perspective. But anyway, all right, so let's just say that that's true, that it's a longer distance. And so that really is a little bit weird. because I don't remember it being, I thought it was a frame issue. But anyway, the point here I'm going to make is that the time it takes to get back and forth from Mars has to be at least, what, 5 minutes or something? I mean, something like that? I mean, 2 minutes? It doesn't really matter. It's minutes. And the sun's moving that whole time. So, how the hell did... I'm just going to call bullshit for that alone. But I mean, how much signal can you imagine they're getting back? They're sending their whatever to Mars and then have it reflect back, okay, and they're supposed to be getting like some sort of, I mean, some sort of substantial signal back. You know, there's nothing to say that it just isn't simply the sun diffracting the, so say that Mars was a little, you know, they're showing it this way. I don't think these drawings are even accurate to their own theory, because there's no way they couldn't get the deflection that far away from the sun. As I've already explained, the gravity out here is less than the gravity on Earth. So obviously this drawing is way out of line. So they're saying that Mars is behind the sun, and the light, and what I'm going to argue is what's happening is the radio waves are being diffracted by the particles being shot out by the sun, and then they get to the Earth. But anyway, so I'm calling bullshit. This is bullshit. All this crap is bullshit. Let's see. Signals were sent from Cassini to frequencies. Yeah, well, all these things are dependent on, you know, all of their perfect math, and everything we do is perfect, and we can see a hair on, you know, the surface of you know, a sun, you know, 4 light years away, you know, with their perfect math. Alright, so look, yeah, you need more of this bogus crap.
3 things were in the picture. The top one and the bottom one, they've got spikes there. That actually tells you they're very small. I'm sorry, they're very small. And they're quasars, quasi-stellar objects looking like a star. And they're well across the universe. But about halfway in between is this object, which is actually a galaxy. Actually, it's part of a cluster of galaxies.
I don't know what this halfway in between stuff is. There's obviously nothing halfway between anything here, so I don't even know what he's talking about. But whatever, he knows that's a galaxy, though. He knows it.
The mass is distorting the space around them. And what in fact is happening is that this image we see pretty well directly. The objects over there, say, up at the top there, and the light and radio waves coming straight towards them. But down here, about halfway between, is a galaxy, and the light that would go down below the galaxy and down there somewhere gets bent upwards.
Yeah, you can't see any of this, so I can't really tell what he's talking about.
So we're seeing,
but again, it's just more sloppy shit that anybody could interpret as anything. And then he talks about black holes.
Of a distant galaxy or quasar. Can you see? This is the foreground object, and you get a lovely thing called an Einstein ring.
Right. So the theory is here, this is a lensing. This is lensing. The stuff in the middle, no. Even though it's all the same color, this is lensing. I mean, to me, it looks kind of obvious that this is an emission from this thing, but whatever. Go ahead. You tell me it's lensing. You say so. Based on putrid evidence, in my opinion. I don't even think these bright spots are the same distance from this center. No, they're not. This is a lot closer to the center than this is. So again, they're breaking the lens rules. You can't the lens. You can't do this. You can't move the lens like this in a Newton's ring or an Einstein ring circumstance. You won't get the rings. It's like me with my little light tube, right? I had to get it just right or it fucks the rings up.
That's the light which will bend around in all directions.
Says you.
So this is what we've got: 2 quasars and a galaxy.
I think this one.
And there's a lovely picture
I think this is the better one.
And the mass of this cluster is in fact producing all these lovely arcs.
Right. All these lovely lights. La 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 la. Swirly swirly bits all over the place. Look at all the swirly and doodlies. La 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 la. Dark matter. Oh, well, we haven't found any of that yet, but oh, it's there. It has to be, because this wouldn't make any sense at all without it.
These are the lensing images of a more distant cluster beyond. And incidentally, this is another way of showing there's something there called dark matter. And in fact, dark matter is proving very elusive. The most sensitive system yet to try and find it finished its observing run last week.
Well, you're a pretty heavy guy. Why don't you just walk around and see if something, tends to, you tend to gravitate towards it, and and something invisible. You just have an invisible. Oh, I invisibly fell that way. Oh, fuck this shit. Dark matter. It's been elusive to find the Holy Ghost. That's all it is. The magical matter that doesn't do anything except create convenient gravity and fix mathematical equations. Yes, I'm sure it's there. The mathematics glue. I don't know what he thinks this is, but fuck it. Fuck it. Oh, they all these shooty things, all these, but they're all drawings, of course, and blah, 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 blah. And yeah, this is the stupid gravitational wave crap. So anyway, we'll be done with this. All right. That's enough, right? I mean, there's just... So there's obviously a ton of experiments, all that need debunking, and I certainly don't have time to debunk all of them. But, I mean, you can just... It just doesn't take too much work, to pick at a few of these things and just say, that one's bullshit. That Piro's smiley face is obviously bullshit. I mean, fuck. So, I think I've done my job here. They've all gone loop-de-doo. Let's stir the bent space. Make waves. Oh, that's not an ether theory. No, bent space isn't ether. Let's stir it. Make waves in it. No, it's not ether.